Example 7 says that if alpha and beta, so just two variables, if they are roots of an equation 5x squared minus 10x plus 3 equals 0, find the value of each of the following. It says to find alpha plus beta and alpha times beta. Well, with quadratic equations, if we look at the parameters of that particular equation, so our like a, b, and c values, they tell us all we need to know about what the roots are and what the properties are going to be. You know, we've talked about the discriminant, we've used the quadratic formula, and then when it comes to factoring and other types of thinking about the roots, there are different types of little algorithms to help us. So up here at the top, it says that if we have an equation set up in that general form, then we can actually see that the sum of the roots will actually end up being negative b over a, and the product of the roots will be c over a. So that can be something really useful and easy for us. I mean, that can help us figure out some parts of what we're looking for. So let's do an example here. So we have the equation 5x squared minus 10x plus 3 equals 0. So from here, we can say, okay, well, A says, what is alpha plus beta? Well, that is going to equal negative b over a. So the sum of the two roots, so this is like root 1, and this is root 2. So negative b over a. So that's the same thing as the opposite of negative 10, so 10 over 5, and that equals 2. So the sum of the roots of the equation is 2. So numbers like 1 and 1, or negative 1 and 3, you know, those are potential answers that we could see here. And there you go. So that's one thing that we can look at. Now, the second part, what about the product of the roots? So what's a times b, or alpha times beta? Well, that is c over a. So the product, if you were to take the roots and multiply them together, here you would get 3 over 5. So we would get 3/5. So the sum of the roots is 2, and the product of the roots is 3/5. So it's a little interesting there. Now, we could go through and solve this equation and try to figure out exactly like what these roots are to kind of show you that this kind of gives us a hint as to what we're looking at. I'm going to use the quadratic formula. And so if we were to do that, x equals negative b. So you don't have to do this part in the example. This is just showing you that this information is correct. So be negative b, which is 10, plus or minus the square root of b squared, which is going to be 100, minus 4ac, which is 3 times 5 times 4, which is going to be 60, and then over 2a, which is 10. So we have 10 plus or minus the square root of 40 over 10. And so you could think of this as 1 plus or minus the square root of 40 over 10. And so you can see that if we were to actually add 1 plus the square root of 40 over 10 and 1 minus the square root of 40 over 10, we would actually end up with 2. And if we were to multiply these, we would actually end up with 3/5 as well. So this can help when it comes to factoring and it comes to seeing what you can and can't do. I kind of knew based off of these answers that factoring was going to be kind of difficult. Anytime you see the product of the roots being something strange, that can always occur. But the main thing that you want to look at is just get the equation into general form, and then you can look and see the product and the sum of the roots can help explain different parts of the equation.